Okay, so here we have an atomic trend question. Which atom is larger? And so it's asking you to consider only the trend in atomic size. So if I were to draw a representative periodic table, then I would draw something like this. And we know that the atomic size gets larger in this direction, and it gets larger it gets larger as we go from high to low, and it gets larger as we go from right to left. So if I were to draw the overall trend looks like this. Now, the only question at this point is, well, what about hydrogen? Well, for all three of your periodic trends, including atomic size, ionization energy, and metallic character, we can move hydrogen to this side of the periodic table and put it right next to helium. I know that in previous lectures, we've talked about how hydrogen has the characteristics of nonmetals. And so in this case, this is exactly where you can put it. And so you can use that to answer any question that you get about hydrogen. Okay, so well, what about carbon versus nitrogen? Well, carbon is going to be further to the left than nitrogen, so it's larger. Nitrogen is going to be further to the left than oxygen, so it's larger. And oxygen is further to the left than fluorine, so it's larger. Now that we know where hydrogen is located here and carbon is located there, so we know that carbon is larger. What about carbon versus silicon? Silicon is further down than carbon, so we know that carbon is smaller than silicon. Phosphorus is further to the left than chlorine. Phosphorus is larger. Magnesium further to the left than boron, larger. It's rubidium. It is rubidium versus molybdenum. It's further to the left, and I think it's also, we got to look at our periodic table, it's also further down than molybdenum, so larger. And then bromine versus iodine, iodine further down than bromine, so it's larger. That's how you use a periodic trend. Remember to move hydrogen over there into group 17, and then you'll know every answer for the trend.